There's a point so far from Earth that sunlight no longer feels like home. A place where the solar system thins out, where the sun's power becomes a memory, and where human technology should have died long ago. But one spacecraft is still there, still awake, still sending signals back across the dark. Voyager 1 was never supposed to make it this far. It was built for a short mission, a quick tour of the outer planets, a few years of work, and then silence. Instead, it kept going past Jupiter, past Saturn, past the edge of the sun's protective bubble. And now, in the emptiness between the stars, it is detecting something no human being has ever heard directly before. A faint, persistent hum vibrating through interstellar space itself. Not a voice, not a message, but something stranger. The background resonance of the galaxy. Voyager 1 began as a mission with modest expectations, compared with what it became. Launched in September 1977, it was supposed to spend a handful of years visiting Jupiter and Saturn, photographing them, sending back data, and then fading into irrelevance as its job ended. No one designed it to become the farthest human-made object in existence. No one planned for it to survive nearly half a century. And yet, that is exactly what happened. Part of that miracle came from timing. Roughly every 175 years, the outer planets line up in a way that makes a rare grand tour possible. A spacecraft can use one giant planet's gravity to slingshot itself toward the next, conserving fuel and gaining speed. Voyager 1 and Voyager 2 were built to exploit that extraordinary alignment. It was a once-in-many-lifetimes opportunity, and NASA took it. Even early in the mission, Voyager 1 was already exceeding the boundaries of what it was supposed to be. Just days after launch, from millions of kilometers away, it turned around and captured the first photograph ever taken of Earth and the Moon together from deep space. It was a subtle clue about what this mission would become. Not just a machine gathering data, but a witness carrying humanity farther outward than anyone had dared to expect. Voyager 1 did not become legendary only because it survived. It became legendary because of what it found on the way out. At Jupiter in 1979, it confirmed that the Great Red Spot was not just a colorful feature, but a giant storm larger than Earth itself, raging for centuries. It discovered Jupiter's ring system almost by accident and found new moons. And on Io, it saw something no one had ever seen beyond Earth before. Active volcanoes erupting in real time. Then came Europa, with its smooth, fractured icy surface that looked uncannily like broken sea ice. That image helped ignite one of the most important ideas in planetary science, that beneath Europa's frozen crust, there might be a hidden liquid ocean, a possible habitat, a second ocean world in the solar system. Voyager 1 was supposed to be flying past planets. Instead, it was opening questions about life beyond Earth. At Saturn, it did the same thing again. It revealed that Saturn's rings were not just a few broad bands, but thousands of delicate ringlets shaped by moons in motion. It transformed Titan from a mysterious orange blur into something much stranger, a world with a thick atmosphere cold enough for methane to behave the way water does on Earth. Methane clouds, methane rain, and a chemistry that should not have felt familiar, yet somehow did. And when mission planners chose a trajectory that let Voyager 1 study Titan closely, they made a sacrifice that changed history. They sent the spacecraft permanently out of the plane of the solar system, giving up further planetary exploration in exchange for something unprecedented, a path toward interstellar space. For decades, scientists imagined the outer boundary of the solar system as a broad, gradual transition. The sun constantly emits a flow of charged particles called the solar wind, inflating a giant protective bubble around the planets known as the heliosphere. Beyond that lies interstellar space. The assumption was that the boundary between them would be diffuse, slow, and hard to define. Voyager 1 found something else entirely. In August 2012, the transition happened abruptly. Solar wind particle counts dropped sharply. Galactic cosmic rays surged. The magnetic environment changed. Over about 2 days, Voyager 1 crossed from one domain into another as though it had passed through a membrane. Not a haze, not a gradual fade, but a boundary, thin, sharp, and far more defined than scientists expected. It was the first time in history a human-made object had entered interstellar space. And what it found there was not emptiness. The interstellar magnetic field was stronger than expected, pressing against the heliosphere with much more force than models had predicted. In other words, the galaxy outside the solar system was not quiet and passive. It was pushing back harder than we knew. The sun's bubble was not expanding into emptiness. It was holding its shape against a far more structured, more forceful interstellar environment than anyone had realized. Among all of Voyager 1's discoveries beyond the heliopause, one is stranger than the rest. Between 2017 and 2020, it detected a steady low-frequency hum at around 3 kHz. Not a burst, not a flare, not a one-time event, but a continuous background tone, faint yet persistent, resonating through the plasma between the stars. This was not sound in the ordinary sense that human ears would hear in air. It was a plasma wave oscillation, an electromagnetic vibration moving through the ionized gas of interstellar space. But the effect was extraordinary because the frequency encoded something real and measurable, the density of that plasma. For the first time, humanity was not merely theorizing about the medium between the stars. It was measuring it directly from the inside. Voyager 1 was effectively listening to the local electrical resonance of the galaxy.